Okay, today I'll tell you a few applications that related to that two-dimensional arrays. So now we'll see applications on this addition operation, matrix addition. So this is one application of on using the two-dimensional arrays.
ये matrix addition.
Hello?
Hello,
Yes.
no, nothing, sir.
Okay. So to do this addition operation, you require totally you require two matrices as input, and after adding these two matrices, you will get a resultant matrix, right? So that means in total I require three matrices. So that means three two-dimensional arrays. See how it stdio.h. Matrix addition.c. I'll require three matrices. So first I'll say matrix of size 10 by 10, B matrix of size 10 by 10, and I require one more matrix. I'll say it as a result. So this is also of size 10 by 10. So totally I have taken three matrices, and I'll take a loop control variables for I and j. Okay. So this 10 by 10 is the maximum size of matrix. Okay. So I'll ask the user how many number of rows and columns you want to use. Out of 10 by 10 matrix, every time user is not interested in giving a matrix of 10 by 10. So sometimes he'll give a 2 by 2 matrix, he'll give a 3 by 3 matrix of that is of different sizes, right? So this the 10 by 10 which I have declared here is of maximum size. Out of that maximum size, I'll be using the user required number of rows and columns. So I'll ask the user printf enter the number of rows and columns. So scanf, I'll read the values of these rows and columns from the user. Ampersand rows, ampersand columns. Suppose if user given value is something like this, if user is interested in using a 2 by 2 matrix. So matrix, this is matrix A, so which is of 2 by 2. This is matrix B. Again, this is also of size 2 by 2. And this is my resultant matrix, which is of same size. So this is rows and columns that is given by the user. Okay. First of all, I'll read the values of matrix A. Enter the elements of matrix A. So for reading this, so to read all the elements in a 2 by 2 matrix, you require a for loop. A nested for loop is required here. I less than number of rows. Remember, always I'll say it as rows and columns. Always my outer for loop will represent the row value and the inner for loop will represent the column value. J plus plus. I'll read the values of matrix A, percentile D, ampersand A of I, J. So this whole thing will read all the values of matrix A. So after reading the values of matrix A, now I'll read the values of matrix B again. Enter the elements of matrix B. Again, to read the values of matrix B, again I require a nested for loop again. I less than rows, I less than, sorry, I plus plus. Here also I forgot to write I plus plus. And then for columns, so j equal to 0, j less than uh, columns, a plus plus. So here I will be reading the values of matrix B. Percentile D ampersand B of I B. So this is how I am reading the input, meaning the values of matrix A and matrix B. So now what I'll do is, see, let us say these are the values. The values are like this. 1, 2, 3, 4 are the values of matrix A. 4, 3, 2, 1. These are the values of matrix B. Let us assume user has given these values. Okay. Now, how you will get the value at this position, that is in the resultant matrix, how you will get the value at 0, 0. You tell me how you will get the value in the resultant matrix, which is at 0, 0 position. So this is 0, 0. This is 0, 1. This is 1, 0. And this is 1, 2. Right? So how we'll get the value at 0, 0 position in the resultant matrix? Hello?
Hello.
You know how to get the value at this position in the in a resultant matrix?
Yes, sir.
So the resultant matrix position is you will get by adding the value in the 0, 0 position of A and the 0, 0 position of B. By adding these two values, you will get here. So to get the value at the 0, 1 position, you have to add the value in the 0, 1 position of A and the 0, 1 position of B. So by adding these two, you'll get a value here. Okay. So suppose if I generalize it like this, how to get the value in the position of ij in the resultant matrix? By adding the ij element in the A, ij plus, so by adding these two elements, you'll get a resultant value in the this resultant matrix. Okay, look here how we can write it. So to access it again, I require a for loop. I is equal to 0, I less than rows, I plus plus. J is equal to 0, j less than columns, j plus plus. So to get a result of I, j, you need to add a of I, j plus E of I j. So this is how you'll get the values in the resultant matrix. Okay, this is how I will calculate the value of 0 0 in result, 0 1 in result, 1 0 and 1 2. And now I'll display it. Printf result matrix. The result matrix I'll display. So for this again I require, see, every time I use a two-dimensional array, I require a nested for loop. Whenever I'm accessing, I require this nested for loop. Without using this nested for loop, it is not possible to access the elements in a two-dimensional array. Percentile D. So for after every element, I'll tab space. Result of I j. And after completing each row, I'll say printf slash n. So this is to make or to display every row in a separate line. So all the row elements in a separate line. After completion of my inner for loop, every time I'll use a new line character. So whenever I use a new line character, the control moves to a new line. See, it is asking to enter the number of rows and columns. I'll say 2 rows and 2 columns. And the values enter the elements of matrix A 1, 2, 3, 4. Again, enter the elements of matrix B 5, 6, 7, 8. So this is what my result matrix is. Okay. You understood this? Hello?
Hello.
Yes, you understood or no?
Mm, no, sir. So what is the meaning of coals?
This one.
So what's the meaning of coals?
It is columns.
Yes, sir.
So whenever you take any two-dimensional matrix, it will have rows and columns. Okay. So this represents rows. The line, blue color line which I am drawing here, it represents the number of rows I have. Okay. The yellow color line which I am drawing now, it represents the number of columns. So how many rows we have here? 2 rows. And in each row, I have 3 columns. So we call it as a 2 by 3 matrix. Okay. Hello.
Hello.
Chetan, you are able to follow it?
The little bit.
Chetan Sai,
Yes, sir.
so you able to follow?
Yes, sir.
Okay. So this is how you can do addition operation on matrices. And I'll also tell you one more example. Matrix transpose. So in matrix transpose, what happens is, let us say I have a 2 by 2 matrix. And let us say these are the values in my 2 by 2 matrix. Okay. So, and when I say or when I apply this transpose operation, the values or the elements in the row will change to columns, and the values in the column will change to rows. That means the resultant matrix after transpose, the matrix, it looks like this. This is nothing but the transpose of A. I'll call it as A T. See, 1, 2 are the elements in the first row. So the elements in the first row are placed in the first column. The elements in the second row are 3 and 4. They are placed in the second column. Okay. If you have elements like this, 1, 2, 3, 4, 5, 6. If this is your matrix A, after transpose, you'll get the values like this: 1, 2, 3. This is the transpose matrix of this A. Okay, what are the elements in the first row? 1, 2, 3. So they are placed in this order. Elements in the second row, 4, 5, 6. They are placed in this order. Okay.
Okay.
See, what is the index of this element? It is 0, 1. This is 0, 2. 0, 0. 1, 0. 1, 1. 1, 2. See the indexes here: 0, 0, 0, 1. 1, 0, 1, 1. See, the things which I have written with this yellow color, so they are the indexes. Okay. Suppose if I consider this 2, so what is the position of 2 in the matrix, original matrix? What is the index of 2 in the original matrix? It is 0, 1, right? Hello?
Hello.
Is it okay? The index of 2 in the original matrix is
So what was the question?
Huh?
What is the question?
You getting or not?
I get it. What is the question?
What is the index of the element 2 in the original matrix?
One.
Hello?
One.
1.
Yes, sir.
It is 0 1, not 1.
Yes, sir.
So in the original matrix it is 0 1. So what is the index of 2 in the transposed matrix? It is 1 0, right?
Hmm.
What about 3? The index of 3. Hello? Okay. The index of 3 is 0 2, and in the transposed matrix it got changed to 2 0. Look at 4. So 4 is 1 0. In the transposed matrix it got changed to the same with the 6. The index of 6 is 1 2. In the transposed matrix it is, if any number you consider, the index of that number in the original matrix is, if it is ij, in the transposed matrix this index becomes, got it?
No, sir.
Now what is the index of this 6 in the matrix A? Hello?
One. 0 19.
You can see which I have written in that yellow color on the screen.
Sir, 12.
Huh?
No idea.
Hello? What is the index of 6 on the 6 in the original matrix A?
Sir, no idea.
What I have written on the screen here? 1 2.
Sir, 12 only.
Huh?
12.
It is, don't say it as 12. It is row number 1 and column number 2. You can't say it as 12. It is row index is 1 2. One means it is a row number, 2 means it is a column number. You can't say it as 12. Okay? Okay, the index is 1 2. So here, after changing in the transposed matrix, the index becomes 2 1. So just the indexes are getting changed, exchanging the positions. So 1 2 it becomes 2 1, and 1 0 it becomes 0 1. So if the index, if we make it as generalized, if the index is ij, in the transposed matrix the index becomes ji. Okay, so with this logic I will tell you the program. Okay, I'll consider one array which is of size 10 by 10. In the transposed matrix I'll say it as result, which this is also of size 10 by 10. Okay. Now I'll consider loop control variables I, J, one for rows and one for columns. Okay. First, I'll read the rows and columns. I'll read percentile D, ampersand rows, ampersand columns. So how many rows and how many columns of the matrix that user is entering? Okay, so now user will enter the matrix of that size. Enter the values of matrix A. So for this again, I'll start writing with a for loop. I less than the number of rows, I plus plus. J equal to 0, J less than columns, J plus plus. So scanf percentile D ampersand A of I J. Okay, so with this I'll read the input for the matrix A. So with this input, I am going to transpose this matrix and store in the resultant matrix, which is RES. So I'll access all the elements from the matrix A with this nested for loop. So I want to store a value in the resultant matrix which is of size ij. So how I'll get is by taking the value from ji position of matrix A. If I want to fill the position that is 0 1 in the resultant matrix, I'll get a value from 1 0 position in A and I'll place it in 0 1. So the indexes the indexes will get interchange. From Ji position of A matrix, I'll get a value and that value is placed in the resultant matrix of index ij. And then you can display. The transpose matrix I'm just displaying here. So every time I access a two-dimensional array without this nested for loop, it is not possible. Okay. So printf percentile d. So I'll get a value from a result of I, j, and I'll display it. And after every row, I'll just say /n. So it is asking to enter the number of rows and columns. If I say 2, 3, so that means 2 by 3 matrix means total it will take 6 values. That means in the original matrix, it will have 2 rows. That means the values will store like this. After getting transpose, it will change like this. That means the elements in the first row. So the elements are 1, 2, 3 are in the first row. They'll get into the first column. And the elements in the second row, which are 4, 5, 6, they'll get in the second column. Okay. Yeah, not right ampersand ij. What?
So what's the meaning of transpose?
What is the?
Meaning of transpose.
That is what I am telling. Interchanging the values or elements from row position to column position. Transpose means, suppose if this is matrix A, you have a values or you have matrix like this. Look, you have a matrix like this. In transposed matrix, all the elements in the first row, they'll be stored in the first column. All the elements in the second row, they'll store in the second column. If you have third row, the elements will store in the third column. Okay. Hello. You got it? What is meant by transpose?
Yes, sir.
Okay. With this, I'll stop for today.